All right, here is your really quick lesson 5.7, inequalities in two triangles, or the Hinge theorem. The objective is to apply inequalities in two triangles. So in 5.6, we talked about comparing inequalities in one triangle, right, by using the angles opposite the sides and comparing them. But if you have two triangles that have some similarities in them, you can also compare sides and based on their angle. So the way to think of the hinge theorem, that's where the name comes from, is like the hinge of a door. And so like when you close a door, right, the angle between the door and the frame, or at the hinge, gets smaller, right? And you can see that here, right? As the door closes, this angle gets smaller. As it opens, it gets bigger. So the relationship between the measure of this angle and the length of the opposite side, this is the basis of the SAS inequality theorem, which is called the Hinge theorem. But the key here is that, right, these doors have to be the same size. So this length has to be the same size, and the door has to be the same size. So it's SAS. This length has to be the same as this length. This length has to be the same as this length. So the door opening and the door have to be the same length, and then you can compare the opening side, the other side, right? If it's side angle side, then there's two sides are already taken care of. You know they're congruent, and then you compare that third side. So that's what this Hinge theorem states, that if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is opposite the larger included angle. Right, so in this case we have side angle side, side angle side, and these two angles are not the same, right? If they were the same, they'd be congruent triangles, right? Because their third side would be the same. But if the third side, whatever one has the longer third side, or whichever one has the bigger included angle, then that has the longer side, right? This means this door is opened wider than this door. If you think about if you think of it as a hinge, where they're equal. So let's look at this first example. It's a multiple choice. Which of the following statements must be true? So if we look at this triangle, we have side and side, side and side. So the two included angles. This one's 90, this one's 70. So this SK has to be bigger than UY. SK is smaller. Nope, SK is bigger. So it's going to be this one here. Right? And so you always, we deal with the included angle, you talk about the side across from it. That's the only ones we can compare. Well, it's also the one that's not. We already know the other ones are congruent. That's going to be this one. And since 70 is smaller than 90, then the one across from 70, the YU is smaller than the one across from the 90. Okay, so try this next one on your own, and this is the last thing we're going to do in Chapter 5. What inequality relates LN and OQ in the figure at the right? So take a look at that, press pause, see if you can figure that out, and then check back for the solution. Okay, hopefully you got that LN was greater than OQ, right? And that's because, right, we have 4 and 7, so 4 and 7, so here's our included angles, this one and this one. Then we have to compare them, right? 125 is bigger than 78, so that means the one across from 125, which is LN, is bigger than the one across from 78, which is OQ. All right, that's 5.7. Enjoy.